Now let us see how the atomic radius vary down the group. For example, consider group 1 elements: lithium, sodium, potassium, rubidium and cesium. The atomic radius of lithium is 152 picometer, that of sodium is 186 picometer, potassium 231, rubidium 244 and cesium 262 picometer. So what do you understand from the values? We come to know that atomic radius increases down the group. So as we move from lithium to cesium, atomic radius increases. Similarly, consider the next group, that is group 17. The elements are fluorine, chlorine, bromine, iodine and astatine. Here again we find that as we move down the group, the atomic radius increases. Thus we can conclude that atomic radius increases as we move down the group. Why does the atomic radius increase as we move down the group? To know that, consider the electronic configuration. The electronic configuration of lithium is 2,1, that of sodium is 2,8,1, potassium 2,8,8,1 and so on. Thus, as we move down the group, we find that new shells are being added. That is, principal quantum number n increases. As n increases, valence electrons will be far away from the nucleus. Also, consider the electrons in the inner energy levels. These electrons present in the inner energy levels will shield the outer electrons from the pull of the nucleus. Since the electrons in the inner energy level shields the outer electrons from the nucleus, the valence electrons will experience less nuclear charge, and hence the valence electrons will not be strongly pulled by the nucleus, as a result of which atomic size decreases. So this is the reason why atomic radius increases down the group. We can therefore conclude that atomic size decreases across a period and atomic size increases down the group. If we consider any group, say for example group 1, lithium, sodium, potassium, rubidium, cesium, we can find that lithium is smaller than cesium. And similarly, if we consider any period, for example second period, we can find that fluorine is smaller than lithium. Ionic radii. The ionic radii is estimated by measuring the distances between cations and anions in ionic crystals. Consider the ions lithium, sodium, potassium, rubidium ions. As we go down the group from lithium ion to rubidium ion, we can see that the ionic radius increases. Now consider the ions sodium ion, magnesium ion and aluminium ion. That is, as we move across a period, we can see that the ionic radius decreases. Therefore, the variation of ionic radius across a period and down the group is the same as that of atomic radius. Next, we have to learn out of parent atom and its ion, that is cation, which is larger and why. That is the cation smaller or larger than the parent atom? For example, consider lithium atom and the ion lithium ion. The number of electrons in lithium atom is 3 and the number of electrons in lithium ion is only 2. But in both lithium atom and lithium ion, the nuclear charge remains the same, since the number of protons remains the same in both the atom and the ion. Since lithium ion has fewer number of electrons compared to lithium atom, the charge experienced by the electrons will be more, and these electrons will be strongly pulled by the nucleus. Therefore, lithium ion will be smaller than lithium atom. Or in general, we can say that cations are smaller than the parent atom. It is because the cation has fewer number of electrons. Next, we have to learn out of parent atom and anion, which is larger. That is the anion larger or smaller than the parent atom? For example, consider fluorine atom and the anion fluoride ion. Out of fluorine atom and fluoride ion, which has more number of electrons? Fluoride ion, 10 electrons. Fluorine atom has only 9 electrons. Now what about the number of protons? It is the same in both fluorine atom and fluoride ion. So which has fewer number of electrons? Fluorine atom. So which will be smaller? Fluorine atom. Fluorine atom will be smaller than fluoride ion. Or we can say that fluoride ion is larger than fluorine atom. In general, we can thus say that anion is larger than the parent atom. Thus, a cation is smaller than the parent atom and an anion is larger than the parent atom.